Hello everybody, welcome into another lesson. So today we are going to talk about inequalities for two triangles. Yesterday's lesson we talked about inequalities for one triangle. Today we're going to talk about them for two triangles. There's only two new theorems, though they look kind of long and overwhelming. Don't be alarmed by these. They're actually fairly easy to understand. The first theorem we have is called the side-angle-side inequality theorem. What this states is that if two sides of one triangle are congruent to two sides of another triangle, but the included angle of the first triangle is larger than the included angle of the second triangle, then the third side of the first triangle is longer than the third side of the second triangle. So what does this mean? I've brought in two triangles to illustrate this point. We have triangles ABC and triangles DEF. Here you can clearly see that side AB of the first triangle is congruent to side DE of the second triangle. We can also see that side BC of the first triangle is congruent to side EF of the second triangle. So we got our two congruent sides, right? However, in this case, the measure of angle B is greater than the measure of angle E. So, we have the two congruent sides here of each triangle, but the included angle, meaning that's between the two congruent sides, angle B is greater than angle E. So what this is going to mean, therefore, is that side AC of the first triangle, the length of AC is greater than the length of DF. Since angle B is greater than angle E, that means side AC, the length of that would be greater than the length of DF. And then I got one more theorem that's kind of the converse of this, but it's got a different name. Let me just change a little bit of information here. Alright, this next theorem has a slightly different name. So the next theorem is the side-side-side inequality theorem. This theorem states that if two sides of one triangle are congruent to two sides of another triangle, but the third side of the first triangle is longer than the third side of the second triangle, then the included angle of the first triangle is larger than the included angle of the second triangle. So it's basically the converse of the side-angle-side inequality theorem, is the side-side-side inequality theorem. So once again, to illustrate this, we have triangles ABC and then DEF. We see that side AB of the first triangle is congruent to side DE of the second triangle. We also see that side BC of the first triangle is congruent to side EF of the second triangle. Well, in this particular case, the length of AC of the first triangle is greater than the length of DF of the second triangle. Therefore, what this would mean, the angles opposite those sides, that the measure of angle B would be greater than the measure of angle E. Since AC is longer than DF, that means the measure of angle B is larger than the measure of angle E. That's all that really means. So now we're going to do 8 exercises to put these two theorems into practice. This shouldn't be a super long lesson. This should just be just 8 exercises here. So let's go ahead and get started. We got triangle CAB, then we're about to put another triangle right next to it here. Not my best work, but it's a triangle. FDE is the name of the second one. FDE. Okay. Then what do they give us for this particular case? And then they give us 15 and 14. Alright, so for these next 8 exercises, we have to try to deduce something about these triangles. And I can tell you, I've looked at these 8 exercises, there is a way to do something. They're all going to have a conclusion. So let's look at triangles CAB and FDE. We can see in the first triangle that CA is congruent to the side FD of the second triangle, as well as side AB is congruent to side DE. So we have 2 congruent sides. But if you look at these 2 triangles, the first triangle, side CB, is longer than side FE in the second triangle with a length of 14. So we have 2 congruent sides, but the third side of the first triangle is longer than the third side of the second. What can we conclude? Well, we can conclude that the measure of angle A is greater than the measure of angle D because of the side inequality theorem. So since you have 2 congruent sides in each triangle, but in the first triangle the third side is longer than the third side of the second triangle, that means the included angle, angle A, is greater than the included angle, angle D, of the second triangle by the side inequality theorem. Alright, what's the next one about? Let's draw our 2 triangles here. What do they call these? LJK, triangle LJK, and the next one is PNO. Alright, so we have triangles LJK and PNO. They give us that each triangle has 2 congruent sides, but the measure of this angle is 40 degrees. The measure of this angle here is 41 degrees. So let's see what we can deduce about these 2 triangles. We have triangles LJK and then PNO. In the first triangle, side LJ is congruent to side PN of the second triangle, and then in the first triangle, side LK is congruent to side PO of the second triangle. So we have two congruent sides, but in the first triangle, the included angle, angle L, is 40 degrees. In the second triangle, the included angle, angle P, is 41 degrees. Well, by the side angle side inequality theorem, we can deduce that the length of NO is greater than the length of JK. We can deduce that the third side of the second triangle is greater than the third side of the first by the side angle side inequality theorem. So all we're doing for these exercises is putting these two theorems into practice. That's really all we're doing. By the side angle side inequality theorem, the length of NO is greater than the length of JK. All right, what's next? Good one. Not the best one I wanted to do. Definitely not my best work. Yeah, that's good enough. Okay. TRVS. TRVS. Alright, so we have a big triangle that's split into two. Then we have right here that RV is congruent to SV. Then we have angles 1 and 2. What else are we given? We're also given in this that the measure of angle 1 is greater than the measure of angle 2. They give us that piece of information. Okay, so we have one triangle, TRS, split into two triangles, TRV and then TSV. Let's start with what we know. We know that side RV is congruent to side SV, and then obviously, since both of these triangles share side TV, TV is congruent to TV. So we have two congruent sides of the triangle. We know that much, but we're given that the measure of angle 1 is actually greater than the measure of angle 2. So we got two congruent sides, but the included angle of the first triangle is larger than the included angle of the second triangle. What that means then is that the length of TR is greater than the length of TS. We can conclude that by the side angle side inequality theorem. So since we have two congruent sides in the triangle, but the included angle of the first triangle, angle 1, is larger than the included angle of the second triangle, angle 2, that means the length of side TR is greater than the length of side TS by the side angle side inequality theorem. All right, what's the fourth one? Cab. There's triangle cab. Then we have another triangle here. This is FDE. All right, let's see what they give us here. They give us that CA and FD are congruent. They even give us that AB and DE are congruent. They give us that. This is angle 1, here's angle 2. So what about the angles? They give us that angle 1 is a right angle. Angle 2 is obtuse. Okay, so for these two triangles, triangle CAB and then FDE, we're given that in the first triangle, side CA is congruent to side FD of the second triangle. We're even given that in the first triangle, side AB is congruent to side DE. So we have two congruent sides. That much is true. But we're given in the first triangle that angle 1 is a right angle, meaning it's 90 degrees. In the second triangle, angle 2 is an obtuse angle, meaning it's greater than 90. So that means the included angle of the second triangle is definitely greater than the included angle of the first triangle. If that's the case, then that means that the length of side FE is greater than the length of side CB by the side angle side inequality theorem. So since the included angle of triangle FDE is greater than the included angle of triangle CAB, that means that side FE is greater than side CB by the side angle side inequality theorem. Let me check something here. Okay, good. Y'all can see this fine. All right. And we're halfway through the exercises already. Only 4 more and then we're done. This is a good one. All right, what do we... UNOG. UNOG. So we have a quadrilateral split into 2 triangles for this one. UN has a length of 7, NO has a length of 7, and then both of these angles here are 40 degrees. Now there's going to be a couple things we can deduce out of these triangles, okay? If we look at these 2 triangles, triangles UNG and then triangles ONG, we notice that side UN is congruent to side NO. Both have a length of 7. And then we have an included angle of each. Angle UNG and ONG both have 40 degree angles, meaning they're congruent, right? So we have a side angle and then both share side NG. So obviously side NG is congruent. So we actually can conclude first and foremost that triangle UNG is congruent to triangle ONG. This is going to be by the side angle side theorem. By the side angle side theorem of equality, we can conclude that these 2 triangles are congruent. And then another thing we can conclude then is that there's several more things we can conclude. We can definitely conclude then by CP/CTC that UG is congruent to OG. So side UG is congruent to side OG. What else by CP/CTC? We can conclude that angle U is congruent to angle O. And then last but not least, we can conclude that angle OGN is congruent to angle UGN. All these three by CPCTC. So when we're doing some of these, you might be looking for inequalities, but in this case we actually had equalities, congruences. So ultimately, by the side angle side theorem of equality, we were able to conclude that these two triangles are congruent to each other, which then means by CPCTC that sides UG and OG are congruent, angles U and O are congruent, and then angles OGN and UGN are congruent to each other. So that one was a loaded one. And you see the theorems of equality and inequality kind of go hand in hand. All right, 3 more. So we have another one with one triangle split into two. All right, length of n, length of n. This angle here is 31 degrees. This angle here is 32 degrees. Okay. So we have one triangle split into two, right? What do we know? We know that both sides TA and sides TC have a length of n, therefore making them congruent. So let's state that TA is congruent to TC. We have that much. So we have a side congruent in each, and actually we have a second side since both triangles share side TB. TB is obviously congruent to TB by the reflexive property since both triangles share that same side. So we have two congruent sides in each triangle. But here's one thing. In the first triangle, angle ATB is smaller than triangle CTB. In other words, the measure of angle CTB is greater than the measure of angle ATB. Right? So if we have then two sides of one triangle congruent to each other, but the included angle of the second triangle greater than the included angle of the first triangle, all that can mean then at this point is that the length of BC is going to be greater than the length of AB. That's going to be by the side angle side inequality theorem. So therefore, in the end, we can conclude that the length of BC is greater than the length of AB by the side angle side inequality theorem. 2 more. We're almost there, folks. We're almost there. Another interesting one here. This exercise here is going to prove that not everything is as it appears. Not everything is as it appears. This is definitely going to prove that to you. Alright, so we got 5, 10, 10, 6. Now, just looking at the shape, it looks like a parallelogram, doesn't it? But what do we know about parallelograms? That both pairs of opposite sides are congruent. Well, only both of the 10 sides are congruent. The other opposite sides, one's got a length of 5, one's got a length of 6, so therefore this quadrilateral is not a true parallelogram. It's definitely not a true parallelogram then. Here's angle 1, here's angle 2. Okay. So, what can we conclude here? Well, we can definitely conclude that these 10 sides are congruent in both of these triangles, right? The 10 sides are congruent, so we can definitely mark a couple congruent sides. Now, what else? We know here that this diagonal of the parallelogram that forms both triangles, they both share this diagonal as the side of the triangle. That's congruent. So both triangles have two congruent sides. But if we look at the right side here, the second triangle, we notice that the third side has a length of 6, whereas in the left side of the first triangle, we have a length of 5. So we have one side, we have the third side of this triangle greater than the third side of this triangle, which can only mean that the included angle, the measure of angle 1, has to be greater than the measure of angle 2. How can we conclude that? This is by the side-side-side inequality theorem. So by the side-side-side inequality theorem, we can actually conclude that the measure of angle 1 is greater than the measure of angle 2. I have one more exercise. This one's going to be very interesting. Yes, indeed. This one will be incredibly interesting. So, let's draw ourselves a triangle here. FEDG. FED and then G. Let's see what else we get here. What do they give us about these two triangles? 18, 18. Very interesting. This angle here is 88 degrees. This angle here is 92 degrees. Okay. This is fun. Why is that, you're asking? Well, again, we have one big triangle, GFD, split into two triangles, FEG and DEG. At first, this is going to look rather hopeless, because we can definitely deduce that FG is congruent to DG. That much is true. EG is congruent to EG since both triangles share the same side. But here's the problem. Right off the bat, we don't know anything about the other angles just yet. All we know is that angle FEG and DEG are different measures. Angle FEG has a measure of angle of 88 degrees. The measure of angle DEG has a measure of 92 degrees. Well, the problem is that's not an included angle. That alone is not enough to make a conclusion. But notice how FG and DG both have lengths of 18, right? For just a minute here, we can combine these into one triangle. We'll place congruency markers here on these sides. Remember the good old isosceles triangle theorem. The isosceles triangle theorem states, of course, that if two sides of a triangle are congruent, then the angles opposite those sides are congruent. That means that angle F has to be congruent to angle D by the isosceles triangle theorem. That's great, but that's still not an included angle. That's still not. So what are we going to do to be able to reach a conclusion? Well, ultimately we know what? That the sum of the measures of a triangle add up to 180, right? We have to somehow prove that, or at least mathematically deduce that angle FGE is greater than angle DGE. So what is that going to look like? We don't know the true measurements of angle F and D, but we do know that they're congruent. So that means in this case, it doesn't really matter what value we assign angles F and D if they're congruent. Let's humor this for a second. Let's say the measure of angle D, of course, equals the measure of angle F. Oh, let's say that they both equal 50 degrees, okay? Let's just say it's 50. So what does that mean? We ultimately want to solve for each of the missing angles in these triangles, right? So we can say that the measure of angle EGF, plus 50 plus 88 equals 180, which would give you that the measure of angle EGF plus 138 equals 180, which would then give you that the measure of angle EGF equals 42. So the measure of angle EGF, if we assign this angle 50, the measure of angle EGF would equal 42. Now let's also look here at this triangle. So we want to solve for angle, EGF, we want to solve for angle EGD. So the measure of angle EGD plus 50 plus 92 equals 180, right? This means that the measure of angle, that's EGD, not EGE, the measure of angle EGD plus 142 equals 180, which could only mean then that the measure of angle EGD would equal 38. So by these two examples, we can show now that the measure of angle EGF is greater than the measure of angle EGD. And even if we put in 60 for F and D, or 40 for F and D, or 30 for F and D, it doesn't really matter. We're going to come up with that the measure of angle EGF is greater than the measure of angle EGD. You're always going to come up with that every time, no matter what values you assign angles F and D, since they're both congruent. Now, I'm going to erase these. I'm going to erase this part because it's really going to clutter the board. By doing an example, and you could do other examples if you want, every time you'll come up with that angle EGF is greater than angle EGD. If we can conclude that, then we now have two congruent sides and the included angle of one triangle greater than the included angle of the second triangle. So what does this mean? This means that the length of FE is greater than the length of DE by the side-angle-side inequality theorem. So since in the end we were able to conclude that angle EGF is greater than angle EGD by the side-angle-side inequality theorem, that means that the length of FE is greater than the length of DE. So sometimes you have to dig a bit and remember past theorems and other properties to help you reach a conclusion. because I know at first it looked hopeless, like we couldn't reach one, but we actually can if we apply those other properties that we've learned. So this is it for inequalities in geometry. The next lesson, we're going to start a 6-lesson unit on similar triangles. We're going to go into similar polygons and triangles, which are different than congruent. So the first 2 lessons of that are going to seem like Algebra 1 or even pre-algebra all over again, because we're just going to review ratios and proportions. But that's ultimately how you get into similar shapes, is they're in proportion to each other. So that's why the review for the next 2 lessons that we're going to do of ratios and proportions is so important. So I hope everyone has a good day. Take care.